Happy midweek 7. I hope things are going okay and you're taking care of yourself. I got some feedback on the week 6 homework, and it sounds like it would be helpful to talk about piecewise defined functions, in particular the problems 19 and 20 from the homework. And before we dive straight into the problems, I thought it would be helpful to just talk about piecewise defined functions in general. All piecewise defined functions, they have the same structure, right? So you have the name of the function, and then it's going to have the different pieces. And so each line is a different piece, and you'll see some sort of equation, if, and then a piece, and then something that follows after that. And you're going to have however many of those that there are. There's no limit, so to speak. We can have as many pieces as we'd like. Sometimes, right, they might not write if. It might just be blank, comma, blank. But it's the same idea. That first blank, right, I'm going to jump into the actual example given in problem 19. That first blank tells us what the graph looks like and the second blank, the part that follows the if, tells us where it looks like that. Where the graph looks like that. So as an example, and I'm actually going to start with the second line. That second line tells us that the graph looks like the line y equals negative x when our inputs, or our x values, are less than 0. In other words, when we're on this left side of the graph, right? The left side is when we're less than 0. So if I were to graph that, and I'll do it in purple since I've written it in purple. We just said that the second line tells us that the graph looks like the line y equals negative x whenever our inputs are less than 0, whenever we're on this left side of our graph. So we have the line y equals negative x whenever our input is less than 0. Now there are a few things that I think are worth talking about. One of them being that open circle that I just drew. Right? You might be asking, well, how did we know that that needed to be an open circle? We knew that that needed to be an open circle because it was strictly less than 0. Right? We had x less than 0. We didn't have that or equal to. So we actually can't plug 0 into that piece. Another thing that I want to point out is that we have this arrow up here. Right? And I knew that that arrow needed to be there because it's for all x values that are less than 0. So that includes negative 100, negative 1,000,000, negative 1,000,000,000, all x values. So it goes off forever in that direction, in the negative direction. And then the other thing that I wanted to point out is that I didn't keep this line going, right? I don't have that line keep going past 0 because that's not what our graph looks like when our input's greater than 0. Right? So we need to respect the boundaries of each piece. Right? So this boundary tells me that I can't go past 0. In fact, when x is 0 or greater than 0, so when our input is greater than 0, our graph needs to look like the line y equals x. Right? That's what that first piece tells us. That first line tells us that our graph should look like the line y equals x whenever x is greater than or equal to 0. And our input's greater than or equal to 0, our x is greater than or equal to 0 on this right-hand side of the graph. And here, I could fill in the dot, right? I could have a closed circle because we had that or equal to. So we'll have different pieces. The first part's going to tell you what the graph looks like, and then the second part will tell you where the graph looks like that. Going the other way, right, if we were given the graph and asked to find the equation, in this case we're only asked to kind of find the domain pieces, it's going to be that similar idea, right? This tells us what the graph looks like. And this tells us where the graph looks like that. So, looking at my graph, right, I can see that I have this parabola whenever our input is in that interval. Right, so that starts at 0. And notice that our function was given us as d of t, so our input variable needs to be t. So when t is between 0 and 10, we have that parabola, which is t squared. Then I see this horizontal line at 100, which corresponds to this piece. That, remember, if you have like just a number, that constant, it's just a horizontal line at that number. So in this case, we'll have a horizontal line at 100. And that's going to start at 10. And it stops. Sorry, that didn't show through. That was not better. It stops at 12. And I'll talk about how I got that value in a second. We're left to fill in one more part, right? And it's this last chunk. And I can see that that chunk, right, is happening from 12. I'm going to switch colors. From 12 until 20. So starts at 12, ends at 20. Notice that I had a closed dot here, which is why I had the or equal to here. And then we had a closed dot here, which is why we had the or equal to for that part. So our goal in this problem was just to find the domain pieces, right? Where the graph looked like each function. So we said that the graph looks like t squared between 0 and 10, and so on. And then there's still the question of how did I know that that value was 12? Right? How did I know that this value, I'm going to switch colors actually to purple. How did we know it was 12? The reason that I knew that that was 12 is because looking at where the green, the piece that's highlighted in green, and the piece that's highlighted in blue, those two pieces connected, right? They connected at this point. So what that told me is that I needed to know when did the green piece, which was 100, when did that equal the blue piece, which was that t plus 88. So again, here's the green, here's the blue. Well, if we solve for t, we'll get that t is 12. So that was how I knew that that piece was 12. If you have any questions, please feel free to post them in the Q&A board, and one of us will answer them there. Or, yeah, I would just say post it there. I was going to say you could email me, but it really benefits the whole class when everyone can kind of see the question and the answer. So I hope this helped. If there's any need for further clarification, you can also post that in the Q&A board, and I'll see that, and then I can kind of respond to it with either a video or in text, in writing.